You've been taking bullets, charging it up with kinetic energy.
You turned off the artificial gravity everywhere but in here.
It's quantum entanglement between the quantum states of Posner molecules in your brains.
Do you guys just put the word quantum in front of everything?
I gotta say, we do put the word quantum in front of everything. Hi, I'm Jim Kekelius. I'm a physics professor at the University of Minnesota and the author of The Physics of Superheroes.
Woo! Let's go!
That's a scene from the first Guardians of the Galaxy movie, and as they're making their jailbreak, Rocket turns off the artificial gravity in the space station so that everyone else floats and is unable to get their bearings, and they make their escape.
I told you I had a plan.
Say you're in an elevator, and in the worst case scenario, the cables break and you start free falling. You're no longer feeling the effects of gravity. It's as if you're weightless. You could start doing magic tricks to the other people in the elevator. Say, hey, look at this pipe, and let go of the pipe and it would just float there because it's falling, you're falling all at the same rate. But if you're already standing on the floor, you'd stay standing on the floor. However, anyone who was walking, at the moment they were walking, they were pressing their feet down on the ground and then lifting their feet up. And at that moment, if the gravity was turned off, they would have launched themselves up. And without gravity to slow their ascent, they would keep rising in that way. So the people who were stationary and started to float up, not so much. Anyone who was walking would indeed start to flow up. I'm not quite sure how the artificial gravity is being generated in the space station, and the whole notion of artificial gravity that can be turned on and off at will in generalized locations in the space station, that's a bit too far. Talking raccoons, that part's okay.
My undying fidelity.
So Thanos has just acquired the Space Infinity Stone. And as soon as he has this, he's able to stop Loki's dagger thrust in midair.
Undying. You should choose your words more carefully.
Well, there's actually some real physics behind this. Back in the beginning of the 20th century, Emmy Noether was able to show a deep, intimate connection between space and momentum. Controlling the space stone not only allows you to teleport, but apparently also gives you command over momentum. Loki's dagger thrust is arrested, and all of the momentum is stopped. If you look closely around Loki's arm, you see a little blue glow that's coming from the space stone that's arresting the momentum of his thrust. It's worth noting that in Captain America: The First Avenger, the Space Stone, which was embedded in the Tesseract at the time, is the only Infinity Stone that was actually weaponized by Hydra and used to create force beams, thereby showing that there is indeed a connection between space and momentum. The first Iron Man movie, 2008, the one that started the whole Marvel universe. I love it. Tony Stark, the superhero as engineer, and the engineer as superhero. When he built his first suit in a cave out of scraps, it was made of iron and was very heavy. About 150 pounds, just counting the iron, not counting the weaponry. Then he developed the Mark II, which was titanium. Titanium is lighter than iron and strong. And then in order to combat the icing problem, he used a gold titanium alloy.
Connect to the Cisco, have it reconfigure the shell metals, use the gold titanium alloy from the Seraphim tactical satellite. That should ensure fuselage integrity while maintaining power to weight ratio. Got it?
Now, there are gold titanium alloys. They tend to be very brittle. They're used in dental applications more than anything else. So unless he's fighting, crime boss gingivitis, I don't think that he's really would want to use a gold titanium alloy. So much of the technology, except for the arc reactor, are things that we actually have right now. We have exoskeletons, we have plating, we even have jet boots. The one thing we don't have is a power supply. He has an arc reactor that's about the size of a hockey puck and puts out the power of 3 nuclear power plants. If we knew how to do that, we wouldn't need superheroes, because otherwise you'd have an Iron Man suit, but you'd have to drag a long extension cord behind you in order to have enough power for the suit. One thing that's realistic in this is that we never see him when he engages his boots or shoots a repulsor ray. We never see him press a button or give a voice command. He thinks it and it happens. That's because he has a cybernetic helmet that picks up his thought waves and sends the information to the suit. This is real. Scientists and engineers at the University of Minnesota and at other universities and institutions around the world are developing cybernetic helmets that pick up the very weak radio waves that are generated when we think, amplifying them, sending them via Bluetooth to another device. They're trying to develop prosthetics and treat paralysis, but if you had asked me as a kid when I was reading Iron Man comics, which part in the 21st century would be the closest to reality, the last thing I would have said was the cybernetic helmet.
Why don't you pick on someone your own size?
Ant-Man shrinking down to the size of an ant, even much smaller. When Ant-Man shrinks, he's also able to control his mass. And he shrinks at constant density, so he's very lightweight. When he rides on an ant, for example, he doesn't smush the ant, but when he wants to punch Yellow Jacket, he's able to increase his mass, so there's more force, more momentum behind his punch. How does he do it? In the comics and in the movie, via Pym particles that were discovered by Hank Pym. If they had just given a little bit of lip service to how one changes the size of atoms. They say that they're changing the spacing between the atoms or the space in the atoms. No. The size of an atom is determined via quantum mechanics to be the ratio of several fundamental constants: charge of an electron, mass of an electron, Planck's constant. If, via the Pym field, to adjust, say, the magnitude of Planck's constant, make it 10 times smaller, then the atoms would become 100 times smaller, and the size of an object would shrink uniformly. If you make it 10 times bigger, the size of the atoms would be 100 times bigger, you could become Giant Man.
Spider-Man! Oh my God, this is it! Tell everyone to hang on!
Oh yeah, I see that look in class a lot. So here, Peter Parker Spider-Man needs to stop a runaway elevated train. He shoots out multiple web lines. They stretch a great deal, but they don't break, and he's able to stop the train just in the nick of time. How strong does the webbing have to be for this to work? We can look up the mass of a train. We can estimate its initial velocity by seeing how long it takes to pass city blocks. We can look at the distance over which the webbing stretches. We can estimate its diameter. We can count the number of web lines. And we come up with a tensile strength for the webbing that has to be about 1,000 megapascals, which is equivalent to 145,000 pounds per square inch. But real spider silk has a tensile strength of 1,200 megapascals. If Spider-Man's webbing is anywhere as strong as real spider silk, then this indeed could happen. He's shooting it out of his wrists, which is not what a real spider would do, but we'll just leave that aside. Doctor Strange is a deviation from all the other Marvel movies insofar as everything else in the Marvel Cinematic Universe up till then had some sort of hand-wavy super science type explanation. But here they're going for just full-on magic.
This doesn't make any sense.
Not everything does. Not everything has to.
The notion that there are multiple dimensions is an idea that has been taken seriously by at least some physicists.
What if I told you the reality you know is one of many?
Quantum mechanics is the branch of physics that describes the properties of atoms and how they interact with light. One aspect of quantum mechanics that many scientists find troubling is that it only deals with probabilities. So you can calculate the probability of a measurement giving the electron at a certain location in space and time, but not exactly where that electron will be. One alternative explanation is that there are actually an infinite number of parallel universes. You find the electron at one location, but in other universes, it might be at some different location. So presumably, maybe Doctor Strange is visiting some of these parallel Earths that have undergone significant quantum deviations from our own. As far as the science there, even if they're in a parallel Earth, the fact that their antagonists are able to affect the orientation of gravity locally, I'm sorry, that's just magic. But he's the master of the mystic arts, so I'll give him a break.
Now, I don't know what you plan on doing here.
I've come here to put an end to Loki's schemes.
Then prove it. Put that hammer down.
Yeah, no. Bad call. He loves his hammer.
You want me to put the hammer down?
Thor puts the hammer down on Captain America's shield. In the movies, the shield is made of pure vibranium, where in the comics, it's an alloy of steel and vibranium. That's actually more realistic. You want steel to provide strength and rigidity, so that when Captain America throws his mighty shield, it will ricochet. But you want the vibranium because it absorbs all vibrations, making it the perfect shock absorber, as it's absorbing Thor's hammer blow in this scene.
It's completely vibration absorbent.
Energy can't be destroyed, it can only be converted to another form. The energy of the hammer strike is converted into sound waves in the hammer. And if the vibranium absorbs it, what form does it take? What we see from the clip. It's converted into blue light, ultraviolet light, this enormous flash of light that's given off. Is showing that the vibranium is actually a perfect sonoluminescent material. Sono meaning sound, luminescent meaning light. You send sound waves in and you get light out. This is a real phenomenon in physics. The only real difference is that vibranium unfortunately doesn't exist.
You're linked to Janet. It's quantum entanglement between the quantum states of Posner molecules in your brains.
Do you guys just put the word quantum in front of everything?
This is a classic example of quantum mumbo jumbo. There are some real words and real concepts that we use there, but they're used in a context or in connection with other phrases that I just cannot follow. But quantum entanglement is a real thing. If you bring two objects so close together that their quantum wave functions overlap, then they can only be described as a single two-object quantum wave function. And if I bring them very far apart and I don't disentangle them, then they remain connected. So something that's done on this end shows up in the other end, even though they could be on opposite ends of the Earth or opposite ends of the solar system. They would still be communicating to each other because they're still described by one single wave function. Scientists are using this property of entangled quantum states to try to see if they can develop superior computers. They're trying to make the context for a character in the movie Ghost, who is quantum mechanically tunneling through solid objects. A real phenomena, but the way they're doing it just doesn't really make sense. A little bit too much quantum woo. So I'd say less woo, more quantum.
I'm not going to make it.
Keep going.
So here we see the Black Panther and his sister, scientific genius Shuri. She's using a holographically generated car in Wakanda to steer a car the Black Panther has commandeered in South Korea.
Which side of the road is it?
For God's sake, just drive.
Okay, calm down.
What makes Wakanda special is that it's near inexhaustible supply of vibranium, an extraterrestrial mineral that has the ability to absorb all vibrations. The hard light hologram always used to bother me. Holograms are interference patterns created with light. The hologram itself is not an actual object, it is an image. But I thought about it some more. Using sound, you can create regions that have a pressure and exert a force as if they were a solid object. And presumably, if you overlay that with a optical hologram, you would have something that feels solid, but is generated via light. Presumably, using their command of vibranium, Shuri is able to do this and overlay it with an optical hologram, which has no solidity, but still produces a visual image for her to interact with. I don't know if I could create a interference sound pattern overlaid with a hologram to create a hard light object, but surely someone can.
Sure.
Surprising absolutely no one, here we see Carol Danvers, Captain Marvel, showing up in Avengers Endgame, obviously responding to the SOS call sent out by Nick Fury at the end of Avengers Infinity War. We last saw her in the mid-1990s at the end of her own movie, Captain Marvel, where she took off into outer space to try to find the Skrulls' homeworld. She comes back to Earth 25 years later, doesn't appear to be any older. Einstein's special theory of relativity says that all observers, whether stationary or moving, have to agree on the value of the speed of light. For that to be the case, they will disagree about distances and disagree about times. There's an effect called time dilation that if someone is moving very close to the speed of light, to a stationary observer, time will appear to have been moving slower. Say she spends 6 months traveling close to, but not at the speed of light, then 6 months traveling at this velocity would correspond to 24 years passing on Earth. We don't know what's going to happen in Captain Marvel 2, but if any of it involves traveling near the speed of light, then the time dilation effect could easily account for the fact that she doesn't appear to have aged significantly from the last movie. This has been Jim Kikalius, your friendly neighborhood physics professor, and in the words of the legendary Stan Lee, face front, true believer.
What's the matter with you kids? You never seen a spaceship before?
Please bring them over here and hold on for safekeeping.
That is hilarious.